This week's guest on Control Intelligence, the control design podcast that goes deep inside the automation and technology that machine builders and system integrators rely on to keep machines humming, is Stu Shepherd, co-founder and president of Shepherd Solutions. Stu was selected as the winner of the 2025 Joseph F. Engelberger Robotics Award for leadership. He will be recognized at the awards dinner during the Automate show in Detroit the week of May 12th. Let's start with the Engelberger Award. What does the Engelberger Award symbolize to you in terms of achievement or recognition?
Well, it's an incredible honor. I highly respect a lot of the other winners that have received it before me. So for me, it's really an affirmation of the journey of my leadership roles in the robotics industry. I've always believed that if you do the right things long enough and hang in there, that and you work on the real voice of the customer and help people find the real voice of the customer, that good things will happen over time. So I think affirmation would be the one word I'd use to describe it.
So my next question, I know you'd shared a picture with me of you at Christmas time in 1966. You with the robot from Lost in Space. So I'm guessing the answer to this question is going to be obvious, but when did your interest in robotics, when did it start? Was it early on, or did it develop over time?
Yeah, it was early on, but more mechanical things in general. And then I had an opportunity to be a co-op student at Purdue University with General Motors. And during that point in time, I had the opportunity to start becoming involved in machine design and equipment fabrication. And immediately after I graduated from Purdue, I had the fortunate chance to be on a project where a decision was made to try to robotize as much as we could to be able to get the flexibility we needed to adapt to the new manufacturing requirements that we were seeing in the marketplace. So that's what really ignited it, was going from being a co-op student to my first assignment and the mentors I had. They did a fantastic job, frankly, of introducing me to robots, and then the rest is history.
So what about recent robotic developments? What's been of most interest to you recently?
So recently, the explosion in AI has certainly caught everybody's attention, and I'm trying to find the useful places where AI can be practically applied that increases the reliability and the ease of use of the systems. So we're starting to see a lot of those commercial applications evolve, mostly in vision to start with. The other interests are improving the sensing technologies around LiDAR and event-based vision systems, because I'm seeing the speed and the capability of those evolving, and giving that true 3D sense to the robot is incredibly important to improve the ability to apply the robots in more diverse applications.
Well, and can you talk a little bit about public perception of robots? It's obviously in the media quite often recently. Can you talk a little bit about the difference between public perception and the perception within the industry, and how they might be similar or how they might be very different?
Okay. Yeah, it's actually kind of a continuum. You go from one extreme to the other. So one extreme is the general population thinks in terms of robots being humanoids. And while there are humanoids out there, it's still largely science fiction, largely in the movies. And what they're seeing, or what you can do on YouTube videos or in theatrical productions that aren't necessarily real world, but continues to show the future, just like the future was shown back in the 60s and how it's evolved. In some cases, the public is getting a better understanding regarding medical surgical robots that are semi-autonomous robots, but also other places where robots are starting to show up in diagnostics, like CT scanners, or some types of treatment type systems like cancer treatment systems that are radiation based. There's actually a place where it's starting to converge, and that's for the fact that they're starting to understand how robots are being used in companies like Amazon and other places that are posting videos about what's going on inside their plants. Same thing for manufacturing plants like GM and Tesla and others that have posted videos. But the perceptions vary dramatically as you get to those that are actually trying to apply it. So the changes that are coming in the manufacturing side that most people really aren't aware of is that for large enterprises with large volumes of business and throughput, they can justify robots pretty easily, and they kind of understand what robots are all about, and their understanding of the market for robots is very, very clear. What's also emerging are the small to mid-sized manufacturers that have very low volume and high mix requirements for their manufacturing. They're now starting to understand that robots can even be applied in their marketplace. And that's really exciting because there's more small to mid-sized manufacturers and industrial concerns out there than there are of any other market in the world. So that's where there's a great opportunity for growth and adoption of more robotic automation.
Awesome. So those applications themselves at the Automate show, for example, over the years, we would see, of course, machine tending applications and then welding applications. And it seems like the past few years, especially, the number of different applications where robots are integrated has just expanded very quickly.
Yes.
So while the robots themselves, we think of them as machinery, as equipment, a robot, it's a modern marvel of engineering, but
right.
they've almost become a point, there's almost become a point where they're components within another piece of equipment. What are some of the more intriguing examples that you've seen, whether it's at the Automate show or just within your own professional experience, of applications where robots have become components within, whether it's a work cell or another piece of equipment?
Yeah, it's funny. A lot of people won't even recognize there's a robot involved in some of these pieces of equipment.
Absolutely.
A good case of that is there's some entertainment systems out there that have robots that are actually the prime movers that are carrying or moving people or moving scenery around, and people won't even realize it's robots that are actually doing that.
Mm-hmm.
Also, we're seeing robots getting more involved in high volume food production, both at the farm level as well as in the processing level. A lot of the proteins, chickens and hamburgers and things like that, are actually being processed and managed now by handling through robots, which are actually a better application for automation because they can be more hygienic and at much faster speed to deal with the massive volumes that these people are having to manufacture. So we're seeing quite a bit in there, and it's pretty exciting. Also, robots of different form factors are starting to show up, not only AMRs for inside the plant, but AMRs for outside in the warehouse parking lot for all the trucks and trailers. We're starting to see applications where AMRs are being used to move trailers around in the trailer lot and bringing them back and forth to the warehouse and managing the external world of the parking lot, very much like they do the internal world of the warehouse, with being able to track the materials and deliver the right trailers to the right spots on time and ready to go. So that's been kind of cool. And then there continues to be an ongoing evolution of robots used in hazardous environments for exploratory purposes or safety and other things. So space applications, it's much easier and safer to put a robot in space than it is a human, and you don't have to worry about oxygen and life sustainability and all these kinds of things. Same thing is true underwater. Underwater rovers and other types of devices are much safer to deploy and can probe much deeper into the darks of the oceans that we still surprisingly know very little about, and they're certainly very safe. And then another form factor altogether is the idea of nanobots, which started out as kind of a wild idea, but now is practical for precise applications in human dosing or human treatments of diseases and other types of activities where the robots are extremely small and can be introduced into areas where automation has never been before.
So flipping that same question kind of on its head, instead of thinking of a robot as a component in a machine, let's think about it as an intelligent, adaptable manifestation of the manufacturing process.
Right.
So how might the merging of robotics and agentic AI, for example, change the adaptability of manufacturing and then even affect the fluidity of engineering capacity?
The whole idea of AI, there's lots of different places where it can intersect with what we're doing. Large language models can be used to help us in programming. Large image models can help us with being able to manage manufacturing variation, because there's a limit to what you can automate and have flexibility and speed before you start slowing down the processes or creating quality problems. So AI can help address many of those types of things. The programming is a little bit problematic to think in terms of AI doing programming from a machine learning perspective, because so many of the applications are based on proprietary software. But over time, those applications are evolving, and over time, sensors are evolving. And you're starting to see AI being able to adapt programs and adapt the actual motion of the robot to optimize speed, optimize performance, minimize the jerkiness of the motion, which causes the robot to last a lot longer. So there's a number of things, and for me, the focus has got to be first on ease of use and ease of deployment, because that's still a big limiting factor to automation in general. And then the second part is performance. And then the third part is going to be redeployability or adaptability to real-time changes in the marketplace and even in the application itself. So I think AI plays a big part of that. And anything we can do that speeds the engineering process of taking slow, repetitive things out of the engineering world and moving that to machine automation is a big benefit, because that way people can focus then on the creativity required for figuring out what's next.
Then with the perceived push toward more autonomous manufacturing capabilities, I know we talked about the term cobot, which is a term that it's kind of a buzzword. People like to talk about the collaborative robot, but will the collaborative ability of that robot or cobot become redundant or unnecessary in an autonomous environment, or do collaborative robots have a role in manufacturing applications that run lights out 24/7?
Yeah, it's an interesting question. There's a lot of debates around this. So first off, the term cobot, as we've mentioned, there's a lot of controversy around it. It's really somewhat of an obsolete term, but because marketing got a hold of it, and it's easy to say, that term is probably going to be around for the rest of our natural lives. The real terminology should be a collaborative application, because a collaborative robot, yes, can be used for a collaborative application, but it can also be used in a general industrial application that's not collaborative. It's typically used for form factor or ease of use or ease of purchase or availability. Likewise, traditional industrial robots can be made collaborative through applying the right kinds of sensors and other equipment to them to make them fit the requirements of the collaborative application, whether it be force and speed limited, and then sensors to be able to create speed and distance separation to allow the robots to work side by side. Because in fact, I've applied robots that have up to 1,000 kilograms payload and much bigger than I am into collaborative applications. So the real trick is to focus on the industrial standards and pay attention to the industrial standards and how to use them correctly, and how to do risk assessments to determine what's the right degree of safety to be able to do man and machine working together in the same environment, in the same envelope, and do so safely. There's lots of guidelines that are out there. There's lots of experts that are available. And in fact, we've had very few industrial accidents, relatively speaking, when it comes to robotic automation. So our safety track record is very good, but that doesn't mean we stop and don't continue to evolve and pay attention to it. So I think that what you're going to see is actually convergence of collaborative robots and industrial robots actually coming together with sensor technology to the point where there won't be necessarily the separation of classes of robots, but the focus will be on how do you use the robots, which is really what you should be focusing on, and then how to make that application safe.
So what is the next big thing in terms of robotics? Everyone's looking for the next big change.
Yeah, it's funny. Everybody asks that, right? Everybody's looking for what's next. So from my perspective, there's a lot that's occurred that the public and manufacturers in large are not really aware of. There's a tremendous amount of automation equipment that's available today that can be applied today. And even with the tariffs and all the other kind of crazy things going on, there's a lot that's not been done in this particular country when it comes to automation that's available that can be implemented. So part of the reasons that manufacturers have been reluctant to put in robotic automation to date has been ease of use issues, everything from ease of purchase to ease of deployment to ease of maintenance and moving things around, but also risk or fear of things not going correctly with the robot, or fear that their people won't be able to work with the robots when they finally arrive. So I think the next evolution is going to be manufacturers and suppliers in general focusing more closely on ease of use and ease of deployment, and working on case studies and proof data indicating that the robot systems do in fact produce reliably and have longevity to them so that they can be perceived as a safe investment.
Hmm.
If you've got a robotic system that pays back in 2 years, that's roughly 32 to 37% ROI, which you're not going to get in the stock market. So why are people not moving faster towards investment in robotic automation? A lot of it has to do with that fear of the unknown. And when as companies start delivering more pre-engineered solutions, they're more standardized, easier to buy and easier to deploy, I think that fear factor will go down.
Sure.
And then end users can get into that crawl, walk, run approach of going simple to more complex to larger size systems as they get more experience.
Kind of looking ahead toward the future as well. What about the next generations? Why should or will they be more attracted to STEM curricula, specifically robotics, and how might that impact them in the future, and how might that impact the industry?
Yes, I really believe we have a great opportunity there. People talk about shortage in employment, availability of employees out there in the marketplace. And I think that's because everybody's searching to get experienced employees and kind of overlooking the availability of the youth and the training that they've had. So many students and their parents still think that STEM type curriculum is going to drive them towards manufacturing. There's so many things you can do with the STEM education and in robotics in so many different market sectors that there's just tremendous opportunities out there. So the key is to get the end users to recognize that some of these younger kids coming out of these fantastic STEM programs that are available now may actually adopt and learn faster to be able to deploy and use robotics faster than some of the more experienced guys like us that are, frankly, becoming dinosaurs. Because the students just take the technology for granted. They're used to thinking in terms of AI being available. They're used to doing Python programming. They're working together as teams on these STEM projects and, FIRST projects, with, the robotics FIRST programs.
Sure.
And other things like that. They're much better prepared than what we were, 20 to 40 years ago. So I think it's a real opportunity for companies to move faster with the availability of some of these kids. I mean, I got a high school kid next door that I'm starting to work with now that's just amazing what he's able to accomplish in programming and working with spreadsheets and AI much faster than what I can do.
Right. Kind of almost a native user, just having grown up with the technology.
Yeah, he doesn't know what he can't do, and he's not, hindered by the old habits that we had. The keyboarding skills, even at a younger age, are much better than what most of us had when we were in high school or even later than that. It's fantastic.
Right. Yes, awesome. Well, great answers. Thanks so much for taking the time to speak with me, Stu. It's been a real pleasure. Congratulations.
Thank you
on being the 2025 Engelberger Award winner for leadership. Well deserved.
Mike, thank you, and good luck to you, and we'll see you at Automate.
Yes, listeners, don't forget, Automate runs the week of May 12th in Detroit. Stu will be recognized at the Engelberger Awards dinner. I think tickets might still be available if you haven't gotten yours yet.
Yeah,
I'm sure you have yours.
It's actually free, and there's a fee for some of the other things. But yeah, the event, the overall trade show is free.
Sure. Yes, and there's also a presentation conference track with presentations that has a nominal fee for that as well. But a lot of great stuff there. Automate's one of my favorite shows of the year. There's so much, like I said, every year the number of applications just exponential growth year after year. The
diversity there is unlike any other show on the planet.
Yes, yeah. It's become so much more than just robots and vision systems. It's automation in many regards.